moment of inertia of rigid body This is a rigid body. This is axis of rotation. It is made of large number of point masses. This is perpendicular distance of point masses from axis of rotation. Why we have taken these point masses? Because we know moment of inertia of point mass is mr square. We know this thing. We have already done moment of inertia of point mass mr square, where what is r? Perpendicular distance. Hence we have taken these point masses. Again, moment of inertia of rigid body. This is what? Axis of rotation. Let m1, m2, mn be point masses of rigid body. And R1, R2, Rn be perpendicular distances of point masses from axis of rotation. Then I1, moment of inertia of point mass m1, m1 r1 square. Similarly, I2, m2 r2 square, so on, in mn rn square. Hence, moment of inertia of rigid body that is I. It is I1 of all point masses. It is what? m1 r1 square, m2 r2 square, so on, mn rn square, number 1. Or I, sigma, I is equal to 1 up to n. Mi ri square. This is number 2. This can be rewritten like this. I 1 to n means m1 r1 plus m2 r2 and so on. Let m1 is equal to m2 is equal to Mn is equal to m. Equal point masses suppose किए हमने. Putting in first I, m common, r1 square, r2 square, so on, rn square, m common, I multiply by n, so you have to divide by n, otherwise equation will change. By n. This is m, this is k square. M, total mass of rigid body. And it is m, n are particles. And k is radius of gyration. And it is what? R1 square, R2 square, Rn square by n. It is what? Root mean. This is mean square of perpendicular distances from point of rotation. So this is what k. This is k square. So k is this, and its name is radius of gyration. Hence, product of mass of rigid body and square of radius of gyration called moment of inertia of rigid body. Here it is CG, center of here it is CM, center of mass. This is K. So this is definition of K. This is also total mass is supposed to act at this place. So this is what that radius of gyration. Radius of gyration. This was what axis of rotation. This is what a rigid body. This point is CM, center of mass. This perpendicular distance was K. This is CM. This was K. So this is definition of radius of gyration. Definition. So what is radius of gyration? This is radius of gyration. Perpendicular distance of CM whose CM rigid body, perpendicular distance of CM of rigid body from axis of rotation called radius of gyration. It is denoted by capital K, and capital K was R1 square, R2 square, Rn square by n under the root. So another definition, this is what root mean square. Root, this is mean, this is square of perpendicular distances of point masses from axis of rotation called radius of gyration. Units SI meter, CGS centimeter, dimensions, it is simply radius, dimensions, so it is M0 LT0. This is what radius of gyration. Derive expression for moment of inertia of ring about an axis passing through center of ring and perpendicular to plane of ring. Hence, find across diameter. This is a question. This is a ring. Uniform ring. This is mass. And this is what? Radius. This is at plane of board. The marker is axis about which we want to find moment of inertia. Again listen. Derive expression for moment of inertia of ring about an axis passing through center of ring. This is what center of ring O. And this is axis, marker is axis, the ring is on board. So about this marker, we have to find moment of inertia. This is next. Find it across diameter, next part of the question. Let capital M, mass of ring, R, radius of ring, cut, point mass of length dx from ring. This one, this length is what? Dx. Then moment of inertia of point mass, that is di, small moment of inertia. It is mr square. Why? M is mass and r is what? Radius, about which this is the point of rotation to this distance, perpendicular distance of dx from point of rotation. What is this small m? Mass of this. Two pi r length, mass is capital M. Dx length mass. 2 pi r mass is m. One length mass is 2 pi r and dx length. Again 2 pi r, this length is 2 pi r, circumference 2 pi r, the mass is m. If 1, it is m by 2 pi r. What is the length? Dx. So this small m is this one, right? M. Small m is m dx 2 pi r, r square. R goes with this square. It is mr 2 pi dx. Hence, mi of ring, that is I, means integrate within limits. M constant, R constant, 2 pi constant, they are outside integration dx. Dx is variable. From where? From 0. Okay, dx. यहाँ से पूरी लेंथ 0 to 2 pi r. Not small, it is capital R. This is what moment of inertia of point mass. The total ring integrate. This dx is variable from where to where? From 0 to total. So it is mr 2 pi dx x 0 to 2 pi r. It is mr 2 pi r. Value of x is 2 pi r minus value of x is 0. And not r here. It is m r square 2 pi by 2 pi. 2 pi goes with 2 pi, I comes out to be mr square. This is what moment of inertia of the ring. About an axis which is passing through center of ring. About diameter. Theorem of perpendicular axis. Deleted from syllabus. IZ, IX, IY. This is theorem of perpendicular axis. This was the ring on board. This is diameter. This was axis. Marker is axis. It is IZ. This is Z axis. This diameter x axis, this is I, marker z axis. This is theorem of perpendicular axis. Marker I z, this diameter x, this is y. So IZ we have calculated mr square. IX, ID, IY, it is ID. डायमीटर है ये जेड था तो mr स्क्वायर 2id और id half mr square. Just an idea how to find about diameter. Derive expression for moment of inertia of disk. About an axis passing through center of disk. And perpendicular to plane of disk. Hence find about diameter. This is a question. This is a disk. This is center of disk. This is mass of disk. This one is radius of disk. We have to find the disk is on board. We have to find moment of inertia about an axis which passes through center of disk and perpendicular to plane of disk. This means ये मार्कर के चारों तरफ हमने एमआई चाहिए इसका डिस्क का. अब क्या है ये मार्कर बोर्ड पर परपेंडिकुलर है. दिस इज द क्वेश्चन. तो रिंग का कर चुके हैं हम. डिस्क का लट एम. मास ऑफ डिस्क R. Radius of disk cut a ring of radius x and thickness dx. ये रिंग कट कर ली हमने डिस्क में से. रेडियस इज एक्स एंड दिस इज व्हाट. ये निकाल ली, कट करके बाहर निकाल ली. आप ये समझिए. तो कोई न कोई थिकनेस भी होगी इसकी. डिस्क में से रिंग कट कर ली हम. कट ए रिंग ऑफ रेडियस एक्स, थिकनेस dx. Then moment of inertia of ring. अभी किया था क्या? mx square. M is mass of ring. X is distance from point of rotation. Now we have to find this M. Pi r square area mass is capital M. One area mass M by pi r square. Area of ring 2 pi r 2 pi x is circumference of ring, length of ring into dx. This is area of ring. Area again pi r square is area mass is capital M1. It is pi r square. This area it is M pi r square into 2 pi x dx. Pi goes with pi. Putting this in first di m. This is value of m. It is m by r square two x dx. This was your m and it is x square. So it comes out to be 2m by r square x cube dx. This is what moment of inertia of this ring. Hence, mi of disk integrate 2m common r square common x cube dx. Which one is variable x? Look, value of x, it is 0. Value of x, it is capital R. Smaller value of x, take x. Yes, 0. Greater capital R. So from 0 to R. It is what 2m r square x4 by 4. 0 to R. 2m r square 4 also outside. Value of x is r. 4 value of x is 0. Power 4 is 0. So it comes out to be 1 by 2 m r square r4 to here. This is what moment of inertia of disk. It is half than that of ring. Hence, about diameter. So this is disk, this is diameter, this axis is Z. IZ is IX plus IY. This is what? Theorem of perpendicular axis. This is IZ. Marker is IZ. This diameter X axis, this diameter Y. This is marker Z. All are perpendicular to each other. X, Y, they are perpendicular. Z also perpendicular. So IZ we have calculated. It is half mr square. Ix is ID. Iy is ID. So 2ID is half mr square and ID 1 by 4 mr square. This is about diameter. Moment of inertia of a rod. About an axis which passes through one end of rod and perpendicular to rod. Hence find MI at mid. At an axis passing through mid of rod and perpendicular to rod. ये फर्स्ट पार्ट देखिए पहले. This is a rod. This is axis of rotation where we want to find moment of inertia. This axis is perpendicular to this rod. This length of rod say L, mass say M. But M, mass of rod, L, length of rod. क्या करेंगे? पॉइंट मास लगाएंगे x डिस्टेंस पर. कितना कट किया? dx. क्योंकि पॉइंट मास का मोमेंट ऑफ इनर्शिया पता है हमने. कट पॉइंट मास of length dx at a distance x from axis of rotation. ये axis of rotation x पर ये कर लिया. Then mi of point mass that is di mx square. We know this thing. Point mass we know. Now we have to find mass of point mass. For length L, mass is M. For length 1, mass is M by L. For length dx, mass is M by L into dx. Therefore, di becomes, ये क्या किया हमने? क्या निकाला? Small m, mass of point mass, total length m1, m by capital L. कितनी length कट की थी? dx. So this is this. So it is m by L dx into what? X square. Hence mi of rod, that is I, constant integrate x square dx. What is x? Shortest value, it is 0. Maximum value, it is capital L. It is m by L x cube, add 1 to power, divide by same power. It is 1 by 3 m by l. Value of x is l, cube is there, minus value of x is 0, cube is there. Or I comes out to be 1 by 3 ml square. This is what moment of inertia of rod about an axis passing through one end and perpendicular. Axis at mid. This was the rod. This we know. This is mid. This distance is L by 2. From theorem of parallel axis. Again, it is deleted. IZ mh square plus IC. H is distance between two parallel axes. H distance between two parallel axes. So here IZ is 1 by 3 ml square. Mh square, this is that distance, L square by 4. This is IC from center. So it is 1 by 3 ml square, 1 by 4 ml square is IC, or IC comes out to be 1 by 12. Solve it. ml square. This is a third. This is deleted just for knowledge sake. If we want to find directly, then the same process, hence from this theorem we can find.